Welcome students, this is second lecture of solid state series. Previously, we discussed the difference between crystalline and amorphous. Today, we shall discuss number of atoms in a unit cell, what is a unit cell and a lattice. A unit cell is the smallest component, smallest constituent in a big lattice. Examples, NaCl, MgCl2, these all form lattice. A unit cell is identical as a cube. It is taken as a cube, and in a cube all the edge lengths are equal. So the first unit cell we shall discuss is a simple unit cell. A simple unit cell has 8 corners. As we have a cube, there are 8 corners in it. You have to imagine in each corner one atom. The atom taken here is in spherical shape. जो एटम हमने यहाँ पर लिया है उस क्यूब में वो स्फेरिकल शेप में है. The corner atoms contribution, you need to calculate the corner atoms contribution. जो आपका एटम कॉर्नर पे मौजूद है वो कितनी कंट्रीब्यूशन आपको प्रोवाइड करता है, उस यूनिट सेल को कितनी कंट्रीब्यूशन प्रोवाइड करता है. Now we suppose that in a corner there is an atom. So we have to imagine how much does it share itself or how much can it share itself. Suppose we take an example of a 2D circle. एक 2D circle को अगर 4 भागों में divide करते हैं, equal parts जो है 4 parts में हो सकते हैं, then we get each component to be giving it 1/4. It will be divided as 1/4 each. Now this is a 2D example. We have to consider a 3D. So now we consider a sphere. If in a circle there are 4 parts, in a sphere there can be 8 equal parts. You have to understand the room which you are in right now. Consider it as a cube. And the corners, consider them to be having a sphere each. You have to imagine how many adjacent rooms of sharing can be there. So we have to learn that. In a sphere which is at a corner, it has to be divided, it can be divided into 8 parts. Now the next question is how much each unit cell gets. If it is dividing into 8 parts, how much each does get? The answer is 1/8. आपका एक कंपोनेंट जो स्फीयर का है वो एक यूनिट सेल को कितना दे सकता है अपना 1/8 part. Now there are total 8 spheres in the unit cell. So how much do I get? We have to multiply 8 into 1/8. So I get 1 atom. So in a simple cubic unit cell in which the cube atoms are only at the corners, the total contribution of all the atoms corresponds to 1 atom. Next example we have is FCC, second type, which is face-centered cubic, in which in a cube the atoms are at the corners, which is obvious. Along with that, there are 6 faces, and each face has 1 atom at the center. Now, if I ask you how many of sharing can be done of each face, so the answer is 2 rules. A phase in which there is 1 atom to be shared, there are 2 participations. मतलब आपके पास एक अगर फेस है उस पे एक एटम है तो एक रूम को हाफ कंट्रीब्यूशन उसकी मिल सकती है. There is a 50-50% sharing. So now there are 6 faces and each face is contributing 1/2 parts of it. So how much do I get? What I do is 6 multiplied by 1/2 and I am getting 3 atoms. So now I have to add it. In a face-centered cubic FCC, the atoms which are at the corner obviously, they are contributing me 1 atom totally and the faces are contributing me equivalent to 3 atoms. The total becomes 1 plus 3, 4 atoms. Next, the third type we discuss, it is body-centered cubic, BCC. Now, in this particular unit cell, what we have is the atoms which are at the corners obviously, and there is 1 atom along the corners 1. There is also 1 atom which is at the center of the room. and it is not sharing to anybody here. It is at the center of a particular unit cell. So if I ask you, what is it sharing? It is not sharing with anyone. So the contribution it gives to the particular unit cell is 1. Now I have to add it. What becomes the total number of atoms in it? So we get the corners give me 1 atom contribution and the body centers give me, the center one gives me 1 atom. So the answer becomes 1 plus 1, 2 atom contribution. So what we have summarized here is, if you are having a simple cubic structure, the contribution is equal to 1 atom. If you are having a face-centered cubic structure, the contribution here is of 4 atoms. And if you are having the third type, which is a body-centered cubic BCC, then the equivalence of atom contribution is 2. So here I have finished my today's topic. The next lecture we will cover packing efficiency, which is very important. There are 3 derivations to be done. Please, if you like this video, please subscribe to our channel and stay tuned for more videos. Thank you.